All right, let's take a look. Number 1. Negative 23 plus negative 6. Well, the signs are the same. So you just add them together, and the answer is negative 29. So if you're at negative 23 and you go 6 more in the negative direction, you're going to land at negative 29 on the number line. Let's look at the second one. 13 plus 6 divided by 3 times negative 4 plus negative 2 squared. All right, what's the first thing we do in order of operations? Parentheses. So in the parentheses, we have divide and multiply. Which one comes first? Divide comes first because we're going to work left to right. So 13 plus 6 divided by 3 is 2 times negative 4 plus negative 2 squared. So we still have parentheses. 2 times negative 4 is what? Negative 8, right? 2 times 4 is 8, and a positive times a negative is a negative. Negative 2 squared. So I still have a parentheses here, but there's nothing to do inside of it. We're just holding it to say plus a negative. Is there anything to do inside of this parentheses? No. I can't simplify that inside the parentheses. So after parentheses, what's the next step? Exponent. What is negative 2 to the second power? What does that mean? It means negative 2 times negative 2. And what do you get? Positive 4. A negative times a negative is a positive. 13 plus negative 8 plus 4. And so 13 minus 8, 5. And 5 plus 4 is 9. Your answer to the second problem is 9. Did you put it in parentheses? Do you see how that's in parentheses? That means you're squaring the negative 2. All right, any other questions? And should we have been using our calculator for this one? No. Okay. Do what? Okay. Did you put the negative inside the parentheses when you were checking it? Okay. All right. Any other questions? All right. 3. 8 squared minus 10 plus 3x. People miss a lot of these on their homework. So the first thing that we need to do is parentheses. Anything we can do inside that parentheses? Can I add that 10 plus 3x? No, you cannot add those. Those are not the same thing. So after parentheses is exponent. What's 8 squared? Is that 16? Yes, it's 16. It's 64. That means 8 times 8, not 8 times 2. 64 minus 10 plus 3x. Here's where the big mistake in homework's coming in. What do I need to do? Distribute that negative. That means I'm going to take 64 and I'm going to subtract both of these things. Well, to subtract both of those, that has to be a negative and that has to be a negative. You've got to distribute the negative. This is that Wednesday, that second part of Wednesday that everybody keeps missing because you're not distributing that negative. 64 minus 10 minus 3x. Work left to right. 64 minus 10 is 54. That takes care of this. Minus 3x. And can I do any more subtracting there? No, you can't take 3 x's away from 54. That is your final answer. 54 minus 3x. Negative 4 to the third power plus 3 squared. Okay, so we have exponents. We're just going to hold off on this negative. This negative's going to come down here. What's 4 to the third power? 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. Negative 64 plus, what's 3 squared? 3 squared is 9. And negative 64 plus 9, well, the signs are different, so I'm going to subtract. So you get 55, and is it 55 positive or negative? Negative. The 64 is bigger. It has the greater absolute value. It's negative, so this is negative. Or you could think you start on the number line way down there at negative 64, and you move 9 in the positive direction. Is there any way you're going to get a positive number out of that? Not if you're at negative 64 and you only move 9 places. You're still in the negative, right? So negative 55. Everybody okay with that one? Okay. Number 5. Oh, fractions. Everybody loses their mind over the fractions. All right. Negative 4/9 plus 6/9. Well, is this an addition problem, or are we really going to have to subtract? You're going to subtract because your signs are different. That's a negative and that's a positive. What makes this one easy? They have a common denominator, so there's no math to do. So our denominator is going to stay a 9. And so what's 6 minus 4? Right? You have a positive 6 and a negative 4. What's 6 minus 4? 2. 2/9. What's negative? The 4/9. So I have negative 1/9. There's 4/9. There's 4 negative 9ths. Would you agree? Negative 4/9. And then 6 positive 9ths. 1, 2, 3, 4, 5. And we'll put one more down here. 6. Cross off 0 pairs. And what are you left with? 2/9 that are positive. Does that make sense? 4 negative 1/9. 4 negative 1/9. 6 positive 1/9. Everybody okay with that? Okay. 6. Negative 3/4 plus 5/8 plus 7/4. What's the first thing that we want to do here? Find a common denominator. What do we want to use for our common denominator? So we're looking for a common denominator for 4 and 8. 2. I'm not sure we should go smaller, because if that's dividing, if I'm going to use a 2, that's dividing that by 4, and you can't divide 5 by 4. What do we want to use? 8. Let's use 8. That means this one doesn't have to change, right? So it's going to stay a 5/8. So to get this one to have an 8 for a denominator, we're going to multiply by 2. So that's negative 6/8. 3/4 is equivalent to 6/8. Would you agree? And to get this to have a denominator of 8, what are we going to multiply by? 2. So 14/8. Now we have common denominators across the board. So we have to do what's in the parentheses first. 6 negative 1/8 and 5 positive 1/8. If you cross off 0 pairs, what are you left with? Huh? So if I have 6 negatives and 5 positives, negative 1/8 plus 14/8. And this is a negative and this is a positive, so it's really a subtraction problem. 14 minus 1 is 13/8. Positive or negative? Positive. Can I leave it like that? No, what do I have to do? Divide. 13 divided by 8, it goes one time. 1 and 5/8. Leave it as a fraction. Don't keep annexing a 0 and turn it into a decimal. If it's a fraction problem, you need to have a fraction answer. On your homework, when you have a fraction problem and you write an answer as a decimal, do I know that you probably used a calculator? Yes. You should be able to do these problems without a calculator. All right. Any questions on the first part of Tuesday that you could not use a calculator for? Questions? Okay, let's look at the next part. Evaluate each expression. If m equals 2, n equals 6, and p equals -4. So 1, it's 3m plus 4p. Now we can use a calculator for this, but you should show the substitution. What is happening here with the 3 and m? What operation? Multiplication. So 3 times 2 plus 4 times -4. Now you can use a calculator. Could you put that in your calculator just like that? Yeah, you can. So you can show 3 times 2 plus 4 times -4. And you get the answer of -10. If I worked that out, that would say 6 plus -16. Those have different signs, so you subtract. 16 minus 6 is 10. This one is the greatest absolute value, and it's negative, so that's a negative. But this section, you could use a calculator, so you could have put it in just like that. All right, 2. N squared plus -5. And what is n? 6. 6 squared plus -5. Can I put that in the calculator just like that? Everybody remember how to do that exponent too? We were using it yesterday. 6, and you can use this button right here, x squared. Or if your exponent is different, use this caret button. That means put the next number superscript up top. So 6 squared plus -5. And you should get 31. Or 36 minus 5, and 36 minus 5 is 31. Everybody okay with that? Is this section easier? Okay. All right, 3. 6p to the third power. That means 6 times p to the third power, or cubed. If I was working this out without a calculator, what would I do first? Would I do the exponent first or the multiplying first? Exponent first. And the p is a -4. Clear 6 times -4 to the third power, and you get -384. Everybody see how to do the to the third power? 6 times -4 caret third power. Everybody good with that? The last one, 4. P minus 2 divided by -2. Now this is a little bit different. You have to do the top before you can do the divided by -2. P is -4 minus 2 divided by -2. So if I were to do this on my calculator, I'm going to say -4 minus 2 equals. -4 minus 2 equals, and you get -6. Now -6, I can leave that there, divided by -2, and you should get +3. Make sure on this one, though, that you hit that equal sign and you get the top part is -6. Otherwise, I think you might get the wrong answer. Negative 4 minus 2 divided by negative 2. It didn't like that at all. Negative 4 minus 2 divided by negative 2. Oh, you get negative 3. But that is wrong. You have to hit the equal sign and you have to get negative 6 first. All right, questions? No? Okay. All right, let's look at our notes for today. This is kind of a review. This is a review from 6th grade for every single shape except a circle. Circle is the only shape. The area is new for us this year. And we've already found area of a circle earlier this week. So, first thing we're going to do is we are going to fold. So if you're looking at the inside of your foldable, you're going to take the bottom, fold it up to that line. Then you're going to take the top and fold it down. There's your title. What you looking for? All right, so we're doing area of composite figures. Does anybody remember what that means from 6th grade? Area of composite figures. Well, let's look inside. Let's do a little thinking to see if we can see about what it means. So looking at these examples, what do you think area of composite figures means? Look at these 3 different examples. What do you think a composite figure is? So it's a composite figure is a figure that is made up of different shapes. So we can't just say, hey, let's find the area of a square or area of a rectangle. This is 2 different shapes combined, right? Do you remember doing those last year? They were super fun, right? Super, super fun. So, as we're looking, what do you think, what are the 2 shapes that we're finding the area of here? Emmy? A triangle and a circle, and this is specifically not a whole circle, it's a semicircle, which is half of a circle, right? What are the shapes that we have put together here? A triangle, a rectangle, and a trapezoid. And over here we have a triangle, a rectangle. Specifically, what kind of rectangle? If this is a 7 and this is a 7, a 7, a 7, a 7. Come on. Square. You could recognize a square in 1st grade. The square is all the same size. And then, what is this last shape? A parallelogram. A parallelogram. Ladies, are you done? So, what do you think that we have to do to find the area of these shapes? Do you remember what we had to do? Find the area of each individual shape, and then to find the area of the whole shape, what are we going to do? We're going to add it together. So if we found the area of this half circle, and then we found the area of this triangle, then we would add them together to find the area of the entire composite figure. Okay? So up here, we're going to write that out. To find the area of a composite figure, you're going to find the area of each individual shape, and then add all of the areas together to get a total. All right. Anybody remember the formula for area of a square? So area of a square, area equals base times height. Or you could also call that area equals length times width. You're probably used to calling it either one of those things, base times height or length times width. You can write both of them, or you can just write whichever one is the one you use. Remember, a rectangle is the same. Area equals base times height or length times width. A parallelogram, anybody remember a parallelogram? It's exactly the same. If you were in my 6th grade class, we did an inquiry lab where we cut off this slanted edge, and then we picked it up and we moved it over to there. And what did it make? It made a rectangle. So when you cut this slanted side off and you move it over there, it's basically just a rectangle that's kind of smushed to the side. So it's the same. Area equals base times height. A triangle, if you were in my 6th grade class, with a triangle, we did an experiment with a Post-it note where we found out that it's exactly half of the square. So remember, when you find the area of a triangle, area equals 1/2 of the base times the height. Because a triangle is half of a square or half of a rectangle, depending on the shape of the triangle. So the important part to remember is you have to multiply that by half, or what's the same thing as multiplying by half? Dividing by 2, right? Okay. A trapezoid, that one's a little bit more difficult. Area equals base 1 plus base 2 times the height divided by 2. So it's base 1, whatever the bottom is, plus whatever the top is, multiplying it times the height, and then dividing by 2. So we would call the bottom base 1 and the top base 2. So you have to add base 1 and base 2 together. You have to multiply it by the height, and then you divide it by 2. Because remember, that was like putting 2 trapezoids together to make a rectangle. All right, the last one, circle, we just learned that. Area equals pi r squared. And what do we use for pi? 3.14. R, what is the R? The radius, that's half of the circle, right? The radius is half of the circle. That's an R. It's a little tiny r, but it's an R. There. And then you square the radius. So these are all the formulas that you're going to need for what we're working on. All right, so let's do these example problems. Anybody need more time to write those formulas down? Okay, here we go. So, down here in example 1, let's start with the triangle. So let's start with the triangle shape. And triangle is 1/2 of the base times the height. What's the base of the triangle? What is it? 10, right? If this is 5, over here is 5. So it's going to be 1/2 of 10. And what's the height? 8. Remember, the height goes from the base to the tippy top point on a triangle. Times 8. And 1/2 of 10 is 5. And 5 times 8 is 40. 40 inches squared. (40 inches squared). That's the area of the triangle portion. Now we need to find the area of the circle. Do what? Yeah. I said half of 10 is 5. And that's dividing by 2. 10 divided by... Or if I could have said 10 times 8 is 80. And then half of 80 is 40. Okay. Formula for the circle is going to be pi r squared. And it's a half of a circle, so then we need to divide by 2 because it's half of a circle, right? So pi is 3.14. The radius from the outside edge to the center is 5. 5 squared. And then we're going to divide that by 2. So on your calculator, 3.14 times 5 squared, and you get 78.5, and you divide that by 2, and you get 39.25 inches squared. So the area for this part is 39.25 inches squared. And so to find the area of the whole thing, what are we going to do? Add. Inches squared. 79 and 25/100 inches squared. That is your answer for example 1. Everybody okay with that one? Questions? All right. Example 2, we have a triangle, a rectangle, and a trapezoid. So let's start up at the top with the triangle. The formula is 1/2 of the base times the height. So 1/2. The base, how big is that? Is it 15 or is it 18? It's 15. This is the same length as this, 15 times 15. And the height goes from the base to the top point, so 9. Put that in your calculator just like that. 1/2 times 15 times 9. Put it in just like that. 1/2 times 15 times 9. And you get 67 and 1/2. Do you want to leave it a fraction or do you want to change it to decimal? Which one would make you feel better? Let's change it to a decimal. Second fraction of decimal, 67.5. Centimeters squared. 67.5 centimeters squared. Okay. Now we have what? The rectangle. And that's just base times height. So the base of the rectangle is 15 and the height is 4. 15 times 4. And we get 60 centimeters squared. The last one, which I think is the most difficult, is the trapezoid. It's base 1 plus base 2 times the height divided by 2. So base 1 of the trapezoid is 18 and base 2 is 15. 18 plus 15 times the height. The height's right here. It's 4 divided by 2. Let's do this on the calculator. Remember, after you do the top, you have to hit equals before you hit divided by 2. 18 plus 15. Do you think I needed to put that in parentheses? Yes, you need to do that adding first. 18 plus 15. Now times 4, and you get 132, and then divided by 2. And you get 66 centimeters squared. Anybody have questions about where I got the numbers for base 1 and base 2? Base 1, base 2. So the bottom and the top. Times the height. Hit equals. You get 132, and then 132, we're going to split it in half, and we get 66. Now what do? We know that this is 67 and a half, this is 60, this is 66. So how do I find the area of the whole shape? What do you think, Aiden? Add it together. 67.5 plus 60 plus 66. 193. 193 and 5/10 centimeters squared. My 3 does not look very much like a 3. There we go. 193 and 5/10 centimeters squared is my answer. Questions about example 2? All right, ready to go to example 3? What are the 3 shapes that we have in example 3? What? Huh? Shapes that we have in example 3. We have a triangle, a square, and a parallelogram. All right, so let's start. Triangle. One half of the base times the height. So 1/2, the base is 7 and the height is 4. 1/2 of 7 times 4. 7 times 4 is 28, and half of 28 is 14. 14 yards squared. Can you put that in your calculator just like that? You could. 1/2 times 7 times 14. No, times 4. 1/2 times 7 times 4, and you get 14. So the area of this is 14 yards squared. All right, the square, what's the formula for a square? Base times height. And so the base is 7 and the height is 7. 7 times 7 is 49. And the last shape is a parallelogram. And that's just base times height. And the base of the parallelogram is a 7 and the height is 3. So 7 times 3, and 7 times 3 is 21. 21 yards squared. And so what do we need to do to find the area of the entire composite figure? Add. 14 plus 49 plus 21. 4, 6, 7, 8, 84. 84 yards squared. Your answer for example 3 is 84 yards squared. Do you remember doing these last year? Yes. Do you remember how super fun they were? Yes. Questions? Okay, so we can fold that up and put it on page. Are we on 107? If memory serves me, it should be page 107. What do you think that we're going to call it? Area of composite figures. That's what you're going to put in your table of contents. So just fit it on page 107 and then put it in your table of content. Area of composite figures. Then we'll look at the skills practice. All right, choose one from the skills practice that you want to do together. Make it a good one. James, what do you think? Which one? Huh? 9? 9. Everybody agreed with 9? Okay, let's look at 9. So let's think about what the shapes are. So I see a half of a circle over here. A half of a circle. And then I see a parallelogram there. Right? And up at the top, I see a triangle. All right? So, let's start with the triangle. Okay, so we see that the height is 4. Let's figure out what the base is. Well, if this is the top of a parallelogram, it matches the bottom of the parallelogram. So that's going to be 12 meters. So the triangle is 1/2 of 4 times 12. 1/2 of 4 is 2, and 2 times 12 is 24. So the area of this is 24 kilometers squared. All right. The parallelogram, the base is 12. What's the height? I need you to really pay attention to what the height is, because I see two different numbers that look like they could be the height of that parallelogram. What do you think it is? It is 4. Remember, the height goes straight up. You don't go to the doctor and the doctor looks at your height, and if you're leaning over, they measure your side. Do they? Don't they go from your feet straight up to your head? So this is going to be 12 times 4. So the parallelogram, 12 times 4 is 48. .48 kilometers squared. And then we have this circle. What's the diameter of the circle? So we have a line that goes all the way through the diameter of the circle. What matches that? 5. So if the diameter is 5, what's the radius? The radius is half of 5. What's half of 5? 2.5. So it's going to be pi times the radius squared. And then we have to divide that by 2. Why do we have to divide it by 2? Because it's half of a circle. So let's do this. 3.14 times 2.5 squared. 3.14 times 2.5 squared. And you get 19.625 divided by 2. Let's just call that 9.8. Because the directions say round to the nearest tenth. And now what do we do? Add them up. So we're going to say 24 plus 48 plus 9 8/10. 81 8/10 kilometers squared. Everybody okay with that? Super fun? Yes? I thought so. I thought you would really enjoy it. All right, so let's take a look. This number 4, you're going to have to turn this a couple of times. So it's 2 triangles put together. One is right there for a base and a height. Let's turn this one. This one, our base is 6 and our height is 5. So sometimes you're going to have to turn your paper and find the different base and heights for the different shapes, right? So here I could see base and height. Just depends on how you're going to turn it. So you're just going to have to be careful with how you're looking at them. What's this shape in number 3? It's a parallelogram with a, what's this bottom? A trapezoid. Okay? So if you're having trouble seeing the shapes, come see us. Come check in if you need help. All right. Would you like to work in partners? Okay, go ahead. You can work in partners. You've got about 10 minutes and then we'll finish tomorrow. So bring this worksheet back and we'll finish it tomorrow.